Cybersecurity Terms Recap Part 3. This is Dr. Data. Let's carry on. So we've been talking about all these important cybersecurity terms that's relatively valuable alphabetically. So now we start off with I. Identity and Access Management, also called IAMS or IAMS. It's basically a collection of processes and technologies that help organizations manage digital identities in their environment. So what does that mean? What defines your identity? You've got identities that are based on three different things. What is, what has, what knows. What is what are you, right? Or who are you? Oftentimes by biometrics, facial scans, thumbprints, voice activated. So that's what is. The next one is called what has. What do you have that identifies? It could be a key card, it could be your passport, your ID card. Then the third is what knows. What do you know that others don't know? Might be a PIN, might be a password. So that defines identity, and that also goes into access management, which is once your identity is defined, what can you access? Can you access every part of the organization, every document? No. The whole idea is that your digital identity allows you to only look at things that are within your domain. Right? For example, I'm a university professor. I can't look at somebody else's course, but I can look at other students' grades and everything, right? That are only in my class. I can't look at a student's grade in somebody else's class. However, a student, on the other hand, we both have identities. The student can look at all of his or her grades, GPA, but can't look at other students' stuff, or can't look at what I haven't released yet. So that's access management. So identity is helping you identify or helping identify who you are, or what is, what has, what knows. And access management is once you're identified and you're authorized, what are you authorized to actually look at? Very important to know, right? And then the next one is called IEEE 802.11, which is, or the next one you're going to talk about is also very popular protocol or standards. It's Wi-Fi standards that basically define communications for typical wireless local area networks, right? You use your routers and all that to do that all the time. Next is something called Internet Control Message Protocol, or ICMPs. So an ICMP is nothing but ICMP packets, but it's an internet protocol used by devices to you talk to each other and see if the data transmission has any kind of errors in the network, right? And oftentimes you can see oftentimes these are pings, these are too many packets, and that goes into something called ICMP flood. ICMP flood is a type of denial of service attack performed by an attacker repeatedly sending ICMP packets, right? Like ping packets. So you're sending thousands and thousands and thousands of requests, sometimes millions, right, to a network service to simply overwhelm it. But that's done using ICMP packets, and that's a very important protocol. Next one is something called Internet Protocol, or IP. So IP is nothing but a set of standards used for routing and addressing data packets as they travel between devices on a network. So IP, think of IP as an addressing scheme. It only knows where to go from and who to go to, right? And that is oftentimes the core part of the IP address, which is a unique string of characters that identifies the location of a device. And of course you hear of IPv4, the 4 octets, IPv6 that we may have talked about, and which basically allows for including more and more devices as we're getting more smarter and smarter devices every day, and too many of them. IP addresses had to be expanded from 4 octets to IP version 6, which is now alphanumeric and can control many more billions and billions of devices. Then we come into IP spoofing. Spoofing, of course, is falsifying or deceiving. It's a network attack performed when an attacker changes the source IP of a data packet to impersonate an authorized system and gain access to a network. So what you're doing is you're changing the source IP so that if the firewall has been trained to say, don't accept anything from this IP address, if you spoof it, you're changing that data packet IP, source IP, to say, oh no, this should be allowed. What you're trying to do is you're trying to disguise yourself as somebody who's been marked as persona non grata to gain access to a network. Next one is LAN. A LAN, of course, you've heard this many times, it's local area network, which is basically spans a small area like office buildings, school, home. You see that all the time. We create our own home LAN and you control that with your own, oftentimes your router, and you set it up so that you can only access that particular area. It's a very controlled, that's why it's a local area network. It's a controlled network. The next one is called MAC, or Media Access Control Address. So it's basically a machine address. So every single device will have a very specific static MAC address. It's a unique alphanumeric identifier. Remember, it's static. That's assigned to each physical device on a network. So each will have a dedicated ID. Versus your IP address, which oftentimes, unless it's a static IP, it's typically handled by a dynamic host controlled protocol, which allows you to renew and reuse IP addresses as devices get in or leave the network. Next one is called a modem. Modem is a device that connects your router to the internet and brings internet access to the LAN. So a modem is basically something that is a go-between your router to the vast internet, right? So it's modulation, demodulation, that's how it works, and that basically connects your router to the internet, right? So in order for you to connect, you have to have a router that connects to a modem, that connects to the cabling, and then that cabling goes out into the main internet. Next one's called multi-factor authentication. So multi-factor authentication is a security measure that requires a user to verify their identity in two or more ways to access a system or network. So multi-factor, of course, multiple ways. So you're saying when you authenticate, again, this is a part of identity management, right? Which is you have a phone, right? In that you might have an app like an authenticator or a message service. Now you use something like what knows, like a username and password, and then it suddenly triggers what has mode, which is, do you have a phone? Do you have messaging? And then it sends you a ping where it says either you verify it using a facial recognition, which is who is or what is, or basically another what knows, like a one-time password or a PIN. And so all you're doing is you're using multiple factors to authenticate so that if one single device falls in the wrong hand, you don't end up compromising the entire identity and access management system. Next one is network log analysis. It's a process by examining network logs. So every time something gets into the network, does something on the network, lots of logs are created, right? Whether it's doing something good, something bad, trying to get through something that's marked as don't go there. All you're doing is you're identifying something called events of interest. So this is part of your event management. So you're always trying to figure out, are you doing something that you're not supposed to do? That would automatically flag it and therefore report it, and somebody might reach out to you or something, or the system itself won't allow you to do that. Next one is called network protocols. So network protocols are nothing but a set of rules used by two or more devices on a network to describe the order of delivery of data and the structure of data. So you follow a set of, you have to structure everything just the way we structure a letter. We have headers, you have a body, right? who it's going to, you have a stamp, you have, I'm talking about conventional letters, you have an address and so forth. It's the same thing. You have to follow a set of rules in order to make sure it's going, how data is structured and how the data is delivered from source to destination. Next one's called network segmentation. It's a security technique that divides the network into segments, sometimes into subnets or subnetworks. All you're trying to do is, you might say, some parts of the next network is openly accessible, some part of the network is secure and more private and shouldn't. You see this oftentimes when we set up guest passwords for the router. We create a separate guest domain setup versus your own private setup. The guest setup might remove certain folders, certain files, certain devices, right? On the other hand, the main one, so all you're doing is you're as if doing network segmentation. Next one's called operating system. So operating system is nothing but the interface between the computer hardware and the user. So the operating system, very much like Windows, Mac OS, Linux, these are all operating systems. What do? They are nothing but the interface, right? They talk to so anytime we type something, like every time I'm pressing this key, it's talking to this application called PowerPoint. PowerPoint is now talking to the operating system. In my case, it's a Mac OS. And the Mac OS is now talking to the computer hardware, which is now saving whatever I'm speaking and the visuals that you're seeing in front of you into a particular part of the hard drive using a particular addressing scheme, right? So all types, so it is the interface between the hardware and the user. Next one's called Open System Interconnection, or the OSI model. It's a very famous model. We've talked about it. It's a standardized concept that describes the 7 layers computers use to communicate and send data over the network. Everything from the physical layer, data link, and so on and so forth, your transmission layer, and right into your presentation and application layers, right? So this is very important because every single layer has certain vulnerabilities that attackers try to capitalize on. Next one's called on-path attack, which is an attack where a malicious actor places themselves in the middle of an authorized connection and intercepts or alter the data in transit, very much like a man in the middle kind of setup, right? So you are sitting in between. So what you've done is you've acted as a part of a network where the network connection is being constantly tapped by you. Think of it as tapping. Somebody's as if sniffing or tapping every kind of information that's being sent. They're intercepting it, or they can alter the data that's going through. So it's on path. Oftentimes similar one is a man in the middle kind of setup. Packet sniffing. Packet sniffing is, again, in this case, all you're doing is you're capturing it, right? You're not really altering it, but capturing. So on path alters, here you're capturing and inspecting data packets across a network. So oftentimes packet sniffing can be done as a white hat basis, which is for for proper network management. You can also do it as a black hat hacker, which is for nefarious purposes. Next one's called passive packet sniffing, which is a type of attack where a malicious actor connects to a network hub and looks at all the traffic in the network. So all you're doing is you're sniffing every possible packet. And again, this is from the darker side, from a black hat hacker kind of perspective. Next one's called a patch update. A patch update is nothing but a software and operating system update that addresses security vulnerabilities within a program or a product. So you send a patch. So you send a small patch rather than a new software version, which is like a small fix, very much like we patch a tire if it's leaking rather than replace the tire. So it's a small patch, but it's fixing any kind of a vulnerability. It's very, very important to update your patches that are being sent by the software vendor. The next one is penetration testing. It's a simulated attack. So again, it's a simulated attack, remember. The simulated part is very important. That helps identify vulnerabilities. It's also known as pen testing in systems, networks, websites, applications, and processes, right? So what you're trying to do is you try to attack the system. So this is oftentimes done as both a blue teaming and red teaming approach, but what you're trying to do is you're trying to penetrate a system to break through it, to see what's wrong so that you can fix it. So mind you, the idea is not to disrupt, but to help identify problems and vulnerabilities to fix them. Thank you very much.